Hi everyone, in this second video we will be finishing the front part of the Game Boy. Let's get started. Continuing on where we left, we will create the different buttons of the Game Boy. Here what I will do is that I will create them separately. So I've got into object mode and added a new plane. Still in object mode, I will then scale it down so that it more or less fits the size of a button. And then I will press Ctrl A and apply the rotation and scale. This will make this new size its new default size. I will then enter edit mode to slightly scale it on the x-axis and return back into object mode to orientate it along the button. And this time I won't be applying the rotation. This tip will allow me to then work into edit mode and use the local space of the plane to edit it with ease. Now if I scale it, for example, presses S and X twice, you can see it's scaling along its local x-axis, here along its y-axis. So I will press Ctrl Z a couple of times so that I get back into object mode with my object unrotated, because I want to use circle as a base, not a plane, but you have the general idea now. So back to my original state, I will add a circle with 12 vertices. I think this is going to be way enough. And I will scale it so that it more or less fits the shape we have created before. Then I will get rid of half of this circle, duplicate it and rotate it by 180 degrees, and then I will just connect the vertices. I will then select the outer square shape that is useless now and press X vertices. I will fill this plane and insert faces so that it will create our face loop as usual. Then to properly position the model, I can hold Ctrl, this will activate the snapping tool, and I can target one edge or one vertex of the top part of the original model. I will then extend the loop by pressing double G and then holding Alt, and then I will just go ahead with my extrude and insert technique. I will then select the two extreme vertices and press Shift S to snap my cursor and add a new circle. I will also make it with 12 vertices and scale it down. I will then press Shift D and X twice to move it along the local axis. Press Shift D again, switch to individual pivots, scale down those newly created circles. This will be our button, so we can extrude them down, then extrude them inward and create a grid fill to fill the cap, and we can bevel the outer edges. I will select everything and press Shift N to recalculate the normal. I will then select the outer ring, extrude and scale. With this face loop created, I can now connect it to the external border. I will then add two loop cuts and a bevel to create my classical supporting edge loop. And now I just have to fill in the middle and add a loop cut and fill the outside boundaries. A little reminder we've seen in the previous chapter with the F2 add-on, you just have to press F once to create an edge and then press F again to fill the consecutive faces. In the meantime, I've added a subdivision modifier to check if my shape is looking good, and I've also added a few bevel on the main edges. So the pace is a bit higher than in the previous video because we have already seen all those techniques, so I'm just repeating the same techniques here. The important tip here is to work clever by setting the orientation of our object in object mode, so then we can then use its local space to make modification easily. To create the additional buttons here, I'm using exactly the same method as you've just seen. So if it's not clear for you, just rewind the video and check out what we've just done before. To create the cross controller, instead of extruding vertices following the blueprint, I will create a simple plane and scale it so that it fits the shape of the cross. Then I will create a vertical and horizontal loop cut with Ctrl R, and I will bevel them. This will automatically generate the cross shape for me. Since it wasn't super clear in the viewport, I've re-recorded it separately. So I've added this plane, add 2 loop cuts, press Ctrl B to create the bevel here. I will reduce the number of cuts because I don't want cuts in the middle, and I will get rid of the outward vertices. Now if we double check our reference, each corner are slightly beveled, so I will select everything and press Ctrl Shift B. I will increase the number of cuts to 2 so that I have 3 vertices per angle, and I will get rid of the inner part here. Then I will just fill it and press I to insert face and create my classical face loop. So now we will need to fill the cross shape. So what I will do is that I will first create those 4 faces, add a loop cut in the middle of each and select them, and again use the bevel. This will allow me to generate some kind of new loops that will be aligned with the vertices in the corner. Just get rid of the middle cut by reducing the number of cuts, and then just fill the extremities using the F2 add-on. So this part is a bit more directive because it's hard to explain a specific method here. Once we have created our outer edge loop, it's more a matter of experience to find the good pattern to fill our mesh. So the best thing I can tell you here is just to follow along what I'm doing. This is not something I generally do because education-wise it's not super optimal, but in this case I don't know any other way. Now just hold on for a minute because I will show you something that we will have to modify later on, but you will get the technique. I will duplicate the outer edge of my cross, fill it, use the Insert Faces tool, and then extend by pressing G and hold Alt its boundary. The idea is to create the inner border of the recess for the cross controller. To do so, we will extrude and scale the border we have created and morph it into a circle by simply right-clicking on it and use the Loop Tool add-on. So we need to activate this add-on. Go to your add-on, press Loop, and activate the Mesh Loop Tool. Right-click, go to Loop Tool, and select Circle, and it will generate a circle from the cross. Then I will extrude and scale again to create an outer edge, and I will add several loop cuts. The idea is to increase the geometry between our cross shape and our circle shape. And we will create a projector so that we can use a shrink wrap modifier to project this shape onto a ball or an hemisphere shape. Place it properly. I've selected the outer edge loop of the previously created shape and I've snapped the 3D cursor to it. Since I'm not sure I can show or not the reference image because I don't know if they are copyrighted, this is why I'm not sharing them into the video, but you can access them in the text file provided with the course, and you will have a link to those pictures. To create the concave shape, I've added a sphere and I will scale it on the Z-axis to squash it to the shape I want. I will then enter edit mode, select the top part, press Ctrl+ to extend the selection and get rid of half of the vertices. I will then scale it and put it in place, trying to match the reference image. Please note that I have called this sphere projector. This will allow me to find it more easily in the outliner. I will now select back my cross object and I will add to it a shrink wrap modifier. This will allow me to project the current geometry onto this sphere. So let's add the shrink wrap modifier, select the projector, and as a method we will use the project on the Z-axis in both directions so that our mesh will be projected vertically onto the previously created concave shape. Pressing the slash key on the numpad, I've isolated my mesh so that I can see it, get back into object mode, and right click to shade it smooth to see how it behaves. So again, this is something we will be redoing a little later, because in this case I'm lacking a bit of geometry. But what I want to show you now is how to exclude this outer border from the projection. To do so, we will use vertex group. This will allow us to assign vertices to a group and exclude them from the projection. Vertex groups are very important in 3D because we use them a lot to grow hair, to isolate the mesh, to bind it to an armature, for example. We generally create them by going into the vertex option of the object, click the plus to create a new vertex group in edit mode, name it if you want, and then we will select our vertices and click assign. When you switch to vertex group weight, you can see that it turns red, showing you that those vertices are assigned to the selected group. If I now get back to my shrink wrap modifier and select the vertex group, you will see that it will disable the shrink wrap because we need to invert the influence. Here the shrink wrap modifier is trying to project the outer edge and we want to project the inside instead. So click the double-sided arrow near the vertex group stack and here we are. Now we can bevel this if we want. But as I've told you before, since I like a bit of geometry, you can see that I have some shading issues even when I'm using a subdivision modifier. I need more points to distribute this projection. So I will need to rework it entirely by first adding loop cut to my cross. So I've added a few loop cuts. I will duplicate this outer edge. I will extend it, then extrude and scale and convert it to a circle as we did before. Then I will extrude and scale to create an outer edge loop. I will create additional loop cut in the inside, assign this ring as a vertex group and reproject everything. I will then move the projector in a new collection that I will call projector so that I can easily hide the collection. The projector and the shrink wrap modifier won't be affected even if I deactivate the collection. I will then create a bevel on the inner edge loop so that I have an hard edge. I will go back into object mode, apply the shrink wrap modifier, go back into edit mode and finally extrude my cross controller. I will add a loop cut to create a nice bevel around the outer edge. Once I'm done with this, I will go back into object mode, select the button, the cross controller and finally the Game Boy case, and I will press Ctrl J to join them and make them a single mesh. The next step will be to connect every part one with the other. So the cool thing here is that using our face edge loop and using this method, we have isolated each curved part and they are all finishing with a flat outer surface. So now whenever I will be connecting the different parts, they will blend perfectly because they are all on the same level, and even with the subdivision modifier I won't have any interpolation because all the points will be aligned on the same plane. In this regard, I can slightly reduce the resolution of the outer edge of my cross recess. So I select every 6 vertices and press Alt M to merge them at center. This will allow me to have less vertices to connect to the case and the other buttons. So I will slightly increase the speed of the video because what I will be doing now is pretty straightforward. I will connect the different edges one with the other. First, connect the different edges that are facing one with the other and avoid adding a loop cut if they are not necessary. That's the most important thing. Just add them when they are obvious and when they are running on a straight surface. This is the whole benefit of this method. Creating those different face loops has allowed us to isolate the curved surfaces from the straight one. Now we can freely cut into the straight part to add geometry whenever we need to connect our button to the outer case. So obviously in the end I will have a little shading problem because that will be too easy if I wasn't facing any problem. This is because my vertices were not perfectly aligned on the same plane. So what I will do then is that I will select all the vertices that are on this very plane, the one we've just filled, and I will scale them at 0 on the z-axis and realign them with the outer edge. Since I've been re-recording a lot of different parts sometimes, I just forget to realign my different pieces before I fill everything, etc. So this is why I get those bugs. But if you've been following the tutorial properly, all those surface points should be aligned on the same plane and you will have a perfect shading. So what I do to go fast is that I isolate the different loops so that I can then select the inner face by pressing L while hovering over a vertex. Once I fixed this alignment issue, I've added a parallel loop cut on the side of the Game Boy so that I get a nice and straight outer edge. I then duplicated and lowered the front face of the screen so that it creates for me the LED screen. And the front part of the Game Boy was done. In the next video we will be modeling the back side of the Game Boy. In the meantime, don't forget to like, subscribe, and I'll see you in the next video.